let's take a look at some of this work that we started class with to figure out the parts of a right triangle, how to figure out a missing side of a right triangle, and all that good stuff. So I got this picture right here. Notice my right angles hanging out in the bottom left-hand corner right there. So when I'm talking about a right triangle, sides A and B are called legs, which hopefully you've seen that in other classes before. But kind of the most important side of a right triangle is side C, which is called the hypotenuse, which again, maybe you've seen it before in Dreambox or other classes. And why all this matters is it goes into the stuff about this thing called the Pythagorean theorem. So what the Pythagorean theorem is, it's a theorem that we can use in order to find the missing side on specifically a right triangle. You cannot use it unless you've got that little right angle down in the corner. And the formula that we're using to do that is a squared plus b squared equals c squared, where a, b, and c go back to this right here. So a and b are my legs, and c is the hypotenuse. And that's really the most important part about these problems, figuring out what the hypotenuse is. Because a and b, I can name either of those legs, a or b, it doesn't really matter. The most important part is c. So I'm just going to do a couple problems with you, and hopefully you'll catch on. So if they're giving me a problem where I have to find the hypotenuse, this is how we're going to do it. I think any of these, it's most important to, first thing I want you to do, identify what that hypotenuse is and put a C on it. So in this question, they kind of already told us that all of them, where the X is where C is going to be. An easy way to tell, though, is start at that right angle and go across from it. Whatever's hanging out across from that right angle is going to be my C. And I'll throw A and B on these other pieces. And like I said, it doesn't really matter about A and B. I could have made 5A, I could have made 12B. The most important part is that C. So I'm going to start with that Pythagorean theorem. And I'm going to start plugging stuff in. So we called A 12. We called B 5. And C was X. So I'm going to put that in there too. And then I'm going to do all this math out. 12 squared is 144. 5 squared is 25. Then I'll add those together. And I got 169 equals x squared. Now we talked about putting that in Desmos the other day. So what I'm doing is to undo that x squared, you take the square root of it. So that's going to leave me with just an x. And then when I put 169 in my calculator, it's going to give me that x equals 13. It says here to round to the nearest tenth when necessary. That one I don't have to round to the nearest tenth because it's a perfect square. But some of the other ones on here you are going to have to. So I want you to try 2 through 4 and see where you get. Okay, another type of problem you can get is where they don't give me the hypotenuse, or they do give me the hypotenuse and they don't give me one of the legs. Again, figure out where the hypotenuse is, start at the right angle and go across from it, and that's my C. And then the other two, I can call this A, I can call this B, or you could have called XB and 8A. Doesn't matter. But I'm going to do it like that. And then I'm going to start with my formula again and start plugging some stuff in. Now in this case, A was X. We said B was 8. And C was 10. I'm going to do that math out again. Now this one's just a little bit different because I can't just right away take the square root because I need that x squared all by itself in order to do that. So we're going to go back to our equation stuff. First thing I need to do is I need to move this 64 to the other side. Now, my x is alone, number on the other side. I can take my square root, and x equals 6. So now I want you to do number 6 and then 7 and 8 on the next page, and then we'll look at one more kind together. And then you'll be good. So let's scoot down here to, these ones are basically everything you just did, but they're kind of mixed up between finding a leg and finding a hypotenuse, so you're going to try those in a second. But I just want to show you one more thing, and that's testing to make sure you've got a right triangle. So if I've got a right, remember, we can only use this a squared plus b squared equals c squared if we have a right triangle. So if they're giving me side lengths, I can figure out if it's a right triangle just based on plugging it into the formula. The only thing that really matters is that your longest side is always c. So here's what this looks like. If I'm doing number 15, again, a squared plus b squared equals c squared, it's probably easiest to just go in the order that they gave you. So I'll make 10a, and I'll make 15b, and I'll make 16c. And now I'm going to do that math on both sides to see what I get. So I'll square 10, I'll square 15. If I do that out, I'm going to get 325 on this side. On the other side, 20 squared is 400. And now I have to kind of look at that statement that I have at the end. I've got 325 equals 400. That is not true. So I'm going to say, can these three sides form a right triangle? No, they cannot. Let's take a look at number 16 now. I'm going to do the same thing. A squared plus b squared equals c squared. Longest side has to be c. So just make sure that you're doing that. And then I'll plug this other stuff in. And when I do all that out, I'm going to get 625 equals 625, which is true. That is a true statement. So I say, yes, that can form a right triangle. So I want you to, once this video is done, finish off this page. You should have already finished the first one, and then we'll check back in.